This video will continue the discussion of galaxies, including mass, dark matter, and clusters of galaxies. So this is a chart that we've seen before in the series of videos, taking a look at the speed, the orbital speed of stars at some distance away from the center of a galaxy. If the mass of the galaxy was in the center region, then if a majority of the mass was in the center region, then we should expect the stars that are further away to have a slower speed, as the force of gravity would be weaker. Instead, what astronomers find, is that the speed of stars at great distances from the center of the galaxy maintains a certain value. This requires extra mass as we go outward. Only the mass inside the orbit of the object contributes to the orbital speed, and as we're going out here, mass inside these orbits must be kind of filled in with something that creates gravity. It's not stars, gas, and dust, it's dark matter. We'll get back to that. But let me go back one slide here. But measuring the orbital properties of the stars, the size of the orbit and the speed of the orbit, that allows astronomers to calculate how much mass is inside the orbit of the star. And the galaxy's mass can be determined. This mass, of course, includes stars, gas, dust, and dark matter. Okay, clusters of galaxies. We don't find really very many isolated galaxies. They tend to form in groups. And there's two classifications of clusters of galaxies. And so we've seen kind of this behavior before with stars. Open clusters in the plane of the galaxy, globular clusters with those great million of stars or so orbiting the Milky Way center. We don't quite go that far with the rich clusters of galaxies, but identifying a poor cluster of galaxies would be fewer than 50 galaxies. Our local group is on the borderline here. We have in the low 50s for a count of the galaxies. Some of those galaxies are being counted are very small, but kind of on the borderline of being a poor cluster, that the group that the Milky Way is part of. A rich cluster, we get up into the thousands of galaxies, and it just is mind-boggling. The galaxies here are huge collections of stars, gas, and dust, and to have thousands of them associated with each other in one region of space, even though it's a big region of space. Well, why do the galaxies stay in clusters? Why don't they kind of drift off? They have their speeds, their individual speeds. Even though space is expanding, that doesn't lock the galaxies into place. The galaxies have their random motions, up, down, left, right, back and forth, so forth. And why is it that they're able to stay inside the cluster? Why don't they kind of fly away? Well, there's enough gravity to keep them in place, enough force of gravity to prevent these galaxies from kind of evaporating from the cluster. However, if you take a look at the mass that's in stars, gas, and dust, there's not enough mass in those forms. Instead, what keeps the galaxies in place is, again, dark matter. So we have evidence for dark matter from the rotation curves of the stars in a galaxy, with high speed for the stars at great distances from the center of the galaxy. And we have another source of evidence for dark matter. That is, the dark matter provides the gravity necessary to keep galaxies from escaping from their cluster. And this is true at all clusters that are examined. There should be clusters or galaxies escaping from the cluster. They don't. Dark matter is able to keep the galaxies in place. Taking a look at light that is from very distant objects that goes past a cluster of galaxies, it is distorted by the effect postulated by Einstein, that gravity will change the path of light. And astronomers can use this effect to map out dark matter in clusters of galaxies. So the purple shading here, that's not some star glow. That's the representation of where dark matter is in this cluster of galaxies. And all the light you see here are galaxies, unless it has spikes coming out. That would be a star. But dark matter, what could it be? Again, something that has gravity but does not give off light, doesn't absorb light. So WIMPs are one possible name for the dark matter. Weakly interacting massive particles. And not going to go any beyond that. We really don't know what dark matter is. It causes gravity. It does affect the speed of a star going around the center of a galaxy, and it does affect the speeds of galaxies in clusters of galaxies. Okay, galaxies near the Milky Way. So the Milky Way is a very significant galaxy in this local group. There are some smaller galaxies around here, irregular galaxies and elliptical galaxies, dwarf elliptical galaxies. The Milky Way's gravity has somewhat control over these galaxies. This is a sort of an association of galaxies. Then if we take a look at the local group, now we have to also consider the Andromeda Galaxy, and there's a set of galaxies that are more or less controlled by the gravity of the Andromeda Galaxy. The Andromeda Galaxy being larger than the Milky Way. So one characteristic of the local group is we have two large spiral galaxies, Milky Way and Andromeda. Milky Way and Andromeda. Another characteristic, the count is in the low 50s now for the number of galaxies in this local group. So it's borderline a poor cluster of galaxies. If we go further away, now we start to see bigger clusters, the Virgo Cluster of galaxies, and different groups here. You can these dots are galaxies, and they're clustering and not totally isolated, but you can see some of them being identified, local group back in towards the center. The Virgo Cluster out here is a little bit richer in the low hundreds of galaxies in the Virgo Cluster. And then going further away, the Coma Supercluster. This is a cluster of clusters of galaxies, a supercluster. So it's not just one cluster of galaxies, it's a clustering of clusters of galaxies, if you can wrap your head around that. And these superclusters are not just spherical. We get some extended lines, some filaments, and you can see that in other places on this diagram. But the superclusters tend to have sort of a filament shape in their structure. If I go back to the Virgo cluster here just a little bit and describing, as I say, hundreds of galaxies, there are spirals, there are irregulars, and then towards the center there tend to be more elliptical galaxies. And I say that because the same thing happens for the Coma supercluster. There are thousands of galaxies here. Most of them are elliptical. However, there are spirals on the outer edge of this supercluster. And some astronomers believe, and maybe I should say most astronomers believe, that the elliptical galaxies are a result of collisions of galaxies. And towards the center of the Coma cluster, the density is higher, and there's not much space between galaxies compared to the distance between stars. Stars are very far apart compared to the size of the star, but galaxies are only 20 or 30 times the diameter of the galaxy from each other. That's extremely close compared to the scale of stars being separated. So collisions between galaxies are not rare. There are many photographs of galaxies in collision with each other. So the thinking is the elliptical galaxies are caused by the collisions of other galaxies. There are more ellipticals in the center of a galaxy, more spirals in the center of a cluster of galaxies, more spirals on the edge of a cluster of galaxies, where the collisions are less common because the density of galaxies is smaller. So we have clusters of galaxies. We have our local group with the Milky Way and Andromeda dominating the local group of roughly 50 galaxies. It's kind of a poor cluster of galaxies. On the order of 50 or less would be a poor cluster. And we have these rich clusters like the Coma supercluster, where we get thousands of galaxies involved with that situation. All the way along out here, it's not shaded in here, but there's dark matter that's playing a very significant role of keeping these clusters from flying apart. So the galaxies are feeling that force of gravity from dark matter that doesn't emit light but has this pull of gravity. So with that, I'm going to let you write down some questions and ask your instructor those good questions. Stay tuned for more videos.